And here we are with polynomial division. We found out what they are, how to add them, subtract them, multiply them, and now we're going to divide them. We start off with monomials. This is almost just a technicality. Just like with monomials in multiplication, it was just distribution. What happens if we take something like 2x to the 7th power plus 18x to the 5th minus 4x cubed, and I divide that whole thing by 2x squared. How does that work? Well, it actually works out very nicely. Way back, there was something we did with fractions, like what was 2/7 plus 3/7? What was that? Oh, that was 5/7, of course. Notice that we kept the common denominator and added the numerators. In fact, if we would have done x/7 plus 2/7, it would have been, no, not 2x/7, that was times x plus 2 all over 7. Notice that this equal sign could go either way. So if you started off with a polynomial divided by a monomial, you can break it up into its individual fractions, which is exactly what happens. You can have a 2x to the 7th over 2x squared plus 18x to the 5th over 2x squared minus 4x cubed over 2x squared. Now you're just back to the rules of exponents. The 2's cancel and you're left with x to the 5th. This x, 18 and 2, you get a 9. X to the, subtract exponents cubed, minus 4 divided by 2 is 2, and there's an x left over. And you're done. That is division of monomials. You just break it up into these individual things. And you might end up with a fraction when you try simplifying it, but then you'll just get exponents on the end. All right, let's go on to regular polynomials. We start looking at the division of polynomials by looking at what happened when we established how to divide normal numbers. Let me give you an example. 2, 3, 4, 7 times 8. When we did that and we multiplied all this out, let's see what happened. We had something like 7 times 8 was 56. You carried the 5 up here and put the 6 down here. All right, then what happened? 8 times 4 was 32 plus 5 was 37. So we put the 3 up here and we put the 7 down here. All right, 8 times 3 was 24 plus 3, that's 27. So we put the 2 up there and the 7 down here. And then 8 times 2 was 16 plus 2, 18. And that's where we got the answer. Now let's look and see what happens when we do 18,776 and we divide it, long division, by 8. What happens? Well, certainly 8 goes into 18. We better get 2, 3, 4, 7, but 2 goes into it. 2 times 8 is 16, right? Let's put that right there. And then make sure we remember what happens. We subtract, and 18 minus 16 is 2. Now I'm going to put this in blue. This 2 and that 2 are exactly the same thing. Let's remember what happened at the last stage of this multiplication problem. 8 times 2 was 16 plus 2 gave us 18. 2 times 8 is 16, and that extra 2 to get it up to 18 is right there. Now I'm going to drop down this 7 right here in the right color. And I want you to notice something. This was a 27. There's our 27 right there where I just dropped that down. Now 8 goes into 27 how many times? Goes in 3 times. That's right. And 3 times 8 is 24. When we subtract it, we get a remainder of 3. And we drop down that 7. And again, this 37 that we had right there, there's the 3 and there's the 7. And so the next one, we take 8 goes into 37. How many times? 4. 4 times 8 is 32, and when we subtract it, we get, yep, that's right, it's a 5, and drop down that 6. And that is the original 56 that we got from 8 times 7. Notice what happens for this entire thing. In multiplication, we went from the right to the left, and then we multiplied and added. Notice we are going here from the left to the right, knocking out systematically these columns until we get down and are clear at the very, very end. While we're here, I'm going to change the problem just a hair and remind you what happened to what happens with a remainder. So let's take that guy off right there and see what happens if it wasn't a 56, but was something like a 58. Then down here at the bottom, we would have had a 2 as a remainder. So we would have written 2347 R2, or that was a long time ago, we would have written 2 8s and then reduce that, but we use that as a fractional part. So keep that in mind. We're going to move from the left to the right, and we're always going to divide into and then subtract, divide into and then subtract. Let's keep that same process, and we'll do polynomials in the exact same manner. Here we have a couple of binomials. If we multiply them together, we get 8x squared minus 14x plus 12x minus 21. So that becomes 8x squared minus 2x minus a 21. So if we go and divide these, do the problem 8x squared minus 2x minus 21, divide it by, say, 2x plus 3, like that, then we better get 4x minus 7. Let's make sure we can do this process. 2x plus 3 into 8x squared minus 2x minus 21. And remember how we did it. We took, and we're going to go into it from the left to the right and see how many times this goes into that, and then subtract. So 2x goes into 8x squared 4x times. You'll notice that's where that 4x comes. So now we multiply this whole thing. 4x times this whole thing gives us 8x squared plus 12x. Now remember, what do we do? What process right now? We subtract. That's right. That's very important. So when we subtract this whole thing, we actually get a minus 8x squared and a minus 12x when we put them together here. So that goes away, and then we have negative 2 minus 12 is a negative 14x minus 21. Good deal. So 2x, notice what we did. We just knocked out that column. Now let's times it by something to knock out the next column. 2x times by a negative 7 would knock out this column right here. Negative 7 times 3, you've got to multiply that whole piece and put it down there. Minus 21. And when we subtract it, we get, ta-da, 0. Yeah, there's our answer, 4x minus 7. Great. Let's do another one. But let's have a remainder this time. Here's a problem, 6x cubed minus 19x squared minus 15x plus 29 divided by 2x minus 7. Let's write it a little bit differently. So let's knock out one column at a time. 2x goes into 6x cubed. That's 3x squared times 2x is 6x cubed indeed. Now we finish that by 3x squared times a negative 7 is minus 21x squared. Now, when we subtract, don't forget, we're going to subtract, which will make that a positive 29. So that guy goes away, gone, the column's gone. Negative 19 minus a minus 21x squared is a positive 2x squared. Drop down the negative 15x, good. Now let's move on getting rid of the next column. 2x into 2x squared, that's plus x, just plus x, that'll give it to us. X times 2x is a 2x squared. Notice that when we subtract, that'll go away. Finish that out by multiplying, and we get plus x times a negative 7 is a negative 7x. Okay, let's subtract that. Subtract, again, minus a minus, that'll make a plus there. That's important to remember. 2x squared minus 2x squared is gone. Negative 15x minus a minus 7x. That's negative 8x. And then we drop down the plus 29. Good. And the final one, 2x goes into negative 8x minus 4 times. No x needed on that one. Negative 4 times 2x is a negative 8x. Negative 4 times negative 7 is a positive 28. Now when we subtract, let's make sure and subtract that guy. Subtract. We get negative 8 minus a minus 8. That's gone. 29 minus 28 is 1. So that's with the remainder of 1 over 2x minus 7. All right, let's give you a chance to do some of these on your own.
To the boards!
Okay, go ahead and write these in your video notebook, give them a shot, and then tune back in and we'll show you the answers. See if you got these right. Welcome back. So the first one is with a monomial. That's a nice one. So we have 4b to the 13th minus 9b to the 8th minus 5b to the 5th, all divided by 3b cubed. So this right here is its own problem. 4b to the 13th over 3b cubed gives us 4 over 3. That doesn't simplify. B to the 10th, subtracting the exponents, minus 9 divided by 3 is 3. B to the 8 minus 3 is 5, and 5b to the 5th, again, that one does not simplify, 5/3, and b squared. There you go. Number 2, we have 15x squared. We better write this the good way. 15x squared plus 4x minus 32, all divided by 3x minus 4. All right, let's look and see what we get here. 3x goes into 15x squared, 5x times, which gives us 15x squared. But we got to times by this minus 4 as well. That's a negative 20x. And we get, oh, don't forget to subtract, 24x minus 32. 3x goes into 24x, 8 times, plus 8. So 8 times 3x is 24x. 8 times negative 4 is a negative 32. Subtract, and we get 0. Turns out to equal exactly 5x plus 8. And you could actually check that. Take 5x plus 8 times 3x minus 4, and you better get the larger trinomial back. Ooh, this looks like a big one. Let's see what we got here. So we've write out 15x cubed plus 19x squared minus 24x minus 18 divided by 5x plus 3. All right, let's see what happens. 5x goes into 15x cubed. That's 3x squared. Would have to do that. 3x squared times 5x is 15x cubed. Good, that's what we wanted. 3x squared times 3 is 9x squared. Subtract, don't forget to subtract, and we get 10x squared. Wiped out that column, minus 24x. 5x plus 3, 5x goes into 10x squared. Plus, let me see, 5 into 10 is 2x to x squared. We need another power of x. So 2x times this in front gives us 10x squared plus 6x. And we subtract. Those are gone, and we get minus 30x minus 18. Okay, so 5x goes into negative 30x minus 6 times. And we get minus 30x minus 18. And if we subtract, look at that, it came out with a 0, no remainder. So there is our answer. All right, number 4. This is x minus 3 goes into x to the 4th minus 5x squared minus 35. All right, x goes into x to the 4th, x cubed times. And we get x to the 4th minus 3x cubed. Ooh, you'll notice this is a little bit of an issue. If we subtract these are not like terms. So there is a way to handle this. And let's just do that. Let's take this guy right here and slide him out for a minute. Yeah, just move him right over here. Yeah, like that. And we'll probably have to move the other guy over just a little bit more as well. Let's take that, and we've got to make sure we have a column for each one of these. So really what we do is we need to insert these non-terms. There are no x cubeds and there are no x's, but that'll allow us to have this same column or a very standard column all the way out to the end. There we go. So now when we subtract, we get a positive 3x cubed minus 5x squared. Good. X goes into 3x cubed 3 times. 3x squared times. There we go. So we get 3x cubed minus 9x squared. Subtract, don't just add them. Those are gone, and negative 5 minus 9 is positive 4x squared. We drop down that 0x, that imaginary term that isn't really there. X goes into 4x squared, 4x times. 4x times x minus 3 is 4x squared minus 12x. And then we subtract, and notice that 0 is coming in really handy to give us a term that is like to the 12x. So we get positive 12x minus 35. And x goes into 12x 12 times. So that's a plus 12. We get 12x minus 36. Subtract, and this gives us 1 left over. So we actually get a remainder on this. So this is plus 1 over x minus 3. So there's our whole big kit and caboodle answer. Whew, those are big. Nice job. To introduce synthetic division to you, we have here a polynomial divided by x minus 2, and there's something special about this. Leading coefficient is a 1, and it's a binomial. When this happens, there's something neat that happens with the numbers here when we go through the long process. X goes into 2x cubed. Well, since this is leading coefficient, we're going to get this number, and it's going to drop this exactly 1 power. And when we times it, we're going to get 2x cubed minus, so 2 times negative 2, that's negative 4x squared, and then subtract it. So this is going to end up plussing. So we get a negative 3x squared and then drop down the 10x. And notice what happens here. That will go into that with the exact same coefficient, minus 3x, drop it a power. And then that times that will give you a positive 6x. Oh, negative 3x squared plus 6x. Subtract. And so 10 minus that number ends up being the opposite of negative 3 times negative 2 is a positive 6. And we get the opposite of it, which is now positive 4x minus 7. X goes into there, plus 4 times. 4 times x is 4x minus 8. And when we subtract, we get a positive 1 as a remainder. So we'll get plus 1 over x minus 2. They have set up what's called synthetic division, which really these x cubes and x squareds and x's just keep things organized in columns. So you can actually set this up in the x cubed column, x squared column with a negative 7, and just write the coefficients out there, a plus 10 and a minus 7. And then if you do a negative 2, that's great, this minus 2, but you don't really need to keep the x around because it always follows that coefficient. And instead, if you take the negative 2 and make it a 2, then you get to add instead of subtract. So what happens is you take this guy and opposite sign right there, so that when we do this operation, we will add all the time. So first of all, this x minus 2 goes to a 2, and write down the coefficients. This was the x cubed column. Let's keep that in mind. So this is how synthetic division works. 2 drops straight down. 2 times 2 is 4. Okay, so you take that number times this number is 4. Then add straight down. Negative 7 plus 4 is a negative 3. And notice what we're ending up with right here in this device. This is negative 3 here. 2 times negative 3 is a negative 6. 10 times added to negative 6, not times. 10 plus a negative 6 is 4. Notice we got that 4 right there. 2 times 4 is 8. Negative 7 plus 8 is 1. And so this is what happens is we had an x cubed and we divided out the x minus 2, this linear factor. And so now each of these drop down a power. This was x cubed, x squared, x, and the constant. This is now 2x squared minus 3x plus 4. And this guy right here is the remainder. And notice what we have as the answer, 2x squared minus 3x plus 4. Let's do another problem just like it before we send you some on your own. Okay, here we have a problem. 3x cubed plus 15x minus 7 divided by x minus 3. So the first step is to take the opposite of this guy. That will allow us to do everything with addition in synthetic division. Take these coefficients. 3, 15. Uh-oh, we're missing one. You remember how we would have had to put that 0x squared in? You do have to do that. There's 0x squared. You got to go x cubed, x squared, and then the x is a positive 15, and then a negative 7 on the end. And then go ahead and draw your line. So add straight down. Negative 3 times 3 is negative 9. 0 plus a negative 9 is negative 9. Negative 3 times negative 9 is positive 27. 15 plus 27 is 42. Negative 3 times 42 is negative 126. Negative 7 and negative 126 is negative 133. So this was an x cubed. It now drops a power down to an x squared. And so we have 3x squared minus 9x plus 42 with a remainder of negative 133 over x plus 3. Synthetic division is very slick, and if you do it, if you're able to do it, you should definitely do it, and it will knock x cubes down to x squareds, and you'll be able to handle them better. So that is how division of polynomials can happen in a synthetic manner, kind of our man-made mechanism to keep track of all those things. So now we'll turn the time over so you can do some problems on your own.
To the boards!
The boards for this one are actually the number 4 from the previous boards in this video. You did this one longhand, and so we're going to give you an opportunity to do it shorthand. Go ahead and pause the video, do it with synthetic division, and see if you get the same answer, and then we'll walk you through it in just a moment. All right, welcome back. Let's set it up. This is x minus 3, leading coefficient's 1, so we get to do synthetic division, opposite of this number, so we do a positive 3. And the coefficient's 1, and this is x to the 4th. Let's keep that in mind. And then we have 0x cubed, negative 5x squared, 0 x's, and negative 35 for the constant term. All right, add straight down, we get 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 5 plus 9 is 4. 3 times 4 is 12. 0 plus 12 is 12. 3 times 12 is 36. Negative 35 plus 36 is 1. I put a box around that to remind me that guy is the remainder. Did not come out even. This was x to the 4th, and we dropped it down a power, dividing it by x's all the time. So that is x cubed now. So the answer is x cubed plus 3x squared plus 4x plus 12, remainder positive 1. Now remember, the remainder goes over what you were dividing by, the x minus 3. And that should have been the exact same answer we got the time before. Good!